Welcome to the Acceleration Exam Study Guide. Let's go through these questions. I'm going to skip email and name, class period, I'm all of them, table numbers, I'm none of them. And here we go, first one. A skateboarder speeds up. We've got everything given to us, and we're just asked to find acceleration, which is already, ooh, I don't like that green color. Our acceleration equation is already set up for acceleration. Final velocity minus initial velocity over t. So in this case, we can plug in VF. It says is 6.0 minus VI is 2.0, all being divided by the time of 2 seconds. Now, if we're doing this step by step, do the subtraction first. 6 minus 2 is 4. And if we're keeping sig figs, we got to say 4.0 because we got to keep the same level of precision as our least precise value. These are equally precise to the tenths place. And then we'll divide by 2.0, which gives us, well, 2.0. Both of these values had 2 sig figs, so our answer should also have 2 sig figs, as it does. And we'll put the units, meters per second squared. On the next question, I'd put meters per second squared for the units for acceleration. On to the next. Number 2, a car slows down uniformly. That uniformly was thrown in to establish that the acceleration is constant. It doesn't vary. But again, we're just looking for the acceleration. We can plug in our final velocity. It's 10. Initial velocity is 25. And our time is 3 seconds. Now this one we talked about in class a little bit, but I'll go over it once again. If we're doing it in steps, we do the subtraction first, which normally, if we were just doing regular old basic math, we of course would say 10 minus 25, well, that's 15. But when you're dealing with science, you are restricted by those significant figures. And this measurement here is very imprecise. It's only known to the tens place. Tens place. Which means it's an estimate. The ones place, we don't actually know what this value is. This number could be 12, could be 13, could be 14, could go the other way too. This number could be 6, maybe it was just rounded up at some point. We don't know. So we have to keep that level of uncertainty, which means I need to round my answer here to the tens place. When I do that, oh, it would be negative, let me put that there. When we round that to the tens place, that'd be negative 20. Negative 20 divided by 3.0. If we do 20 divided by 3, that gives us 6.66666 repeating forever. But we don't list our answers like that in science generally. We're going to round it based on sig figs. We've got 2 sig figs here, 2 sig figs. But this negative 20 is only known to the tens place, indicating that we only have 1 sig fig. And we are restricted based on our least precise value. That's the general motto, which means I need to round my answer to 1 sig fig, which will be right here. That'll round up to 7 meters per second squared. And there we are. So once again, I'd put meters per second squared. Now, one thing to watch out for on the exam, these orders will be mixed up from question to question, so you actually have to pay attention to what you're clicking, otherwise you're going to lose some easy points. Moving on to the next. A runner accelerates steadily. This time we're looking for time, but we're still using that same equation, a VF minus VI. This whole exam that we're doing is just using that one equation. Now, I'm not going to try to solve straight to the answer and make mistakes in my brain. Instead, I'm going to go step by step, plug in my values. The acceleration is given. Final velocity is given. The initial velocity is given. And the time is what we're looking for. Now, one thing we could do right off the bat, we can simplify that top piece. 1.5, 9 minus 3 would just be 6.0, keeping the same level of precision. But to get t by itself, we have to first multiply everything by t. The reason we do that is because, in general, if the variable you're looking for is underneath a fraction, you can't really solve for it. So you got to get it out from under there first. So multiply everything by t, those cross out, we end up with 1.5 t. That's the standard way to write it. And then to get t truly by itself, we can now see to just divide everything by 1.5. And our answer will have two significant figures because our both numbers there have two sig figs. And we get 4. But since we need two sig figs, we'll say 4.0. That's letting them know the time is not roughly 4 seconds, it is precisely 4 seconds down to the tens place, which is a decent level of precision. And then the units, seconds. Next up, a cart starts from rest and speeds up. We're looking for the final velocity. Again, we don't need to do anything fancy. We can just plug in what we've got into that equation we've been using. Acceleration is given, 4.0. Final velocity, we don't know, so I'll just leave that as a variable. The initial velocity, we do know, 0.0. And the time, we also know, 6.0. Now to get VF by itself, it's currently being divided by 6, so we'll just multiply both sides by 6. Those cross out, and 6 times 4, that'd be 12 plus 12, 24. And both of these have two sig figs. Luckily, our answer already has two sig figs, so we're good there. All that's equal to VF minus 0.0. And well, if I take my final velocity and subtract 0, nothing's going to change. So I can honestly just scribble that out at this point and say that my final velocity is 24 meters per second. On to the next. Number 5, third of the way there. An airplane decelerates while landing. That's good. We're looking for acceleration again. Don't have to do any algebra for this one. We just got to plug in our numbers to the right spots. So final velocity always goes first. Then we subtract our initial velocity. That's how we find the difference or the change in velocity. And then to get acceleration, we divide that change of velocity by time. All right, if we're still keeping track of our sig figs carefully, we can do this in 2 steps. First, 18.0 minus 72.5 gives us negative 54.5. And both were known to the tens place, so our answer is as well. That's being divided by 5.5, which, if I toss that into my calculator, I get negative 9.9090909, and presumably it'll just continue that way forever. So we're certainly going to have to round. If we look at our values that we just subtracted, this number's got 3 sig figs, but this one only has 1 sig fig. So our answer, has 2 sig figs, not 1. Has 2 sig figs. So our answer should also have 2 sig figs, which there's 2 right there, right at the front of the number, 9.9. That 9 is not going to round up because the next number is less than 5. Slap on our units, and we're good to go. On to the next. Number 6. A cyclist speeds up gently. We're looking for acceleration. I'll go through this one quick. Final velocity, 5.5, minus our initial velocity, 1.5, divided by 4.0. Since they all have the same level of precision, you could probably get by plugging this straight into your calculator, as long as you remember to put parentheses around that. But to be on the safe side, I'll do it step by step. 5.5 minus 1.5, that gives us 4. But since these numbers were known to the tens place, I'm going to say 4.0, so that is also to the tens place. And if that's being divided by 4.0 already, well, that'll turn into 1.0 to have that second sig fig that we need. Meters per second squared. And mark our meters per second squared. See, it switched the previous problem. It was the fourth option, but this time it's the fifth option, so watch out for that. Number 7, a sprinter slows slightly approaching the line. That seems like a bad strategy. Aren't you supposed to speed up as you cross the line? Oh, maybe he's talking about the starting line. Either way, the story doesn't matter to me, only the physics matters. So I'll take my final velocity, 5.0, subtract my initial velocity, 8.0, divided by the time. Again, you can probably get by just doing it all at once, but for the sake of it, 5 minus 8 will be negative 3.0, because these are both known to the tens place, divided by 1.5. Both numbers have 2 sig figs, so our answer better as well. But it only comes out to be negative 2. So in order to get that second sig fig, we just say 0.0 meters per second squared. And we mark our meters per second squared. On to the next. I'm getting there. Well, my screen will let me move it. There we go. Number 8. A crate is pushed from rest along a smooth surface. We're looking for final velocity. Let me just throw the equation up there as a reference. Now, plugging into that, we've got the acceleration given, 3.0. Final velocity, we don't know. Initial velocity, 0.00. We know that 0 fairly precisely. Divided by 4 seconds. So to get rid of this, or well, trying to get VF by itself, we first have to deal with this divided by 4 business by multiplying both sides by 4, causing those to cancel out, and we get 12. Now notice that I didn't put 12.0. That's because with multiplication, you get your result to the same level or the same number of sig figs as your least precise value, or the number of the least number of sig figs. But in this case, they both have 2 sig figs. So our answer should have 2 sig figs. 12 already does, so I don't need to change it. Speaking of, on the right side now, we have VF minus 0. Once again, that isn't going to do anything, so we can just scratch that out, slap on our units, meters per second, and we're done. Well, done with number 8, I suppose. Then toggle meters per second for my units. On to the next. Number 9. A trolley speeds up to merge with traffic. We're looking for time. Acceleration is given, 1.2. Final velocity is given, 12.0. Initial velocity is also given, 6.0. All being divided by time, but that's what we want to find. So first, if I'm doing this super carefully, I can simplify the top piece. 12.0 minus 6.0 will be, well, 6.0. Then this t is on the bottom of a fraction, so the first thing I gotta do, multiply everything by t to get it out from under there. Now it's up here on the left side. 1.2 times t is equal to 6. And then to get t truly by itself, we'll divide 1.20 from both sides. 6 divided by 1.2 gives us 5. But we need another sig fig because this has 2. This one actually has 3, but we go with the one that has the fewest number of sig figs. So our answer needs 2 sig figs. So I'll say 5.0 seconds. And then toggle seconds. Moving on. 2/3 of the way there, I think. Number 10. A ball rolls down a hallway and is clocked later. Ball rolls down a hallway and is clocked later. That clocked, I'm assuming, just means someone was timing it as it was rolling down the hallway. And then they wanted to figure out what must have been the initial velocity. So sort of think of it like they're at the end with a stopwatch. They didn't see who started rolling the ball, and they're trying to figure out where it came from, perhaps. So a piece of that would be figuring out how fast it was going initially. But not to overcomplicate things, we're still using the same equation as before. Acceleration goes first. And then we do our final velocity minus our initial velocity, which we don't know, divided by the given time. All right. Currently, VI is being divided by 4, so we got to do the opposite to get rid of that. Multiply both sides by 4. Cause those to cancel. And 4 times 0.8 gives us 3.2. And both of our starting values had 2 sig figs. 3.2 does as well, so that's fine as is. Now at this point, we have this positive 7.2 on the right side we want to get rid of. So we'll subtract 7.2 from both sides. 3.2 minus 7.2 gives us -4. Oh, wait. Both these numbers were known to the tens place, so I should really say -4.0. So I have that tens place. And that's equal to negative VI. So here, there's a few ways you can think of it. I always think of it as just multiplying everything by -1, which will turn this into a positive 4.0, turn this into a positive VI. Slap on our units, meters per second, toggle the right units, and we're good to go. Number 11. A scooter increases speed at a steady rate, and we want to know the final velocity. Again, if we're doing this as carefully as possible, acceleration, put that first. That is equal to our final velocity, which we don't know, minus our initial velocity, 3.5, divided by our time of 6 seconds. Got to get rid of the fraction first. VF is being divided by 6, so we need to multiply 6 to both sides, causing those to cancel. 6 times 0.75 gives us 4.5. Quick sig fig check. Both of those have already had 2. Our answer has 2 as well, so we're fine so far. VF minus 3.5. So we're subtracting 3.5 from our final velocity. So to get rid of that, we do the opposite. Add 3.5 to both sides. (4.5) minus 3.5 gives us certainly 1.0 because we need that tens place to match with what we started with. And that's equal to VF. So that scooter, after everything is said and done, hold up, I think I may have made a mistake. Because this says the final velocity is 1, which is slower than what it started as. But it says it speeds up, increases speed. What did I do? Oh, I subtracted over here. At this point here, I said add those, but in my mind, I subtracted and got 1. That's my problem. Let me back that up. 4.5 plus 3.5. 4 and 3 would be 7. 0.5s combined, we get 8. Oh, let me switch back to blue. Having technological issues. There we go. 8.0 is equal to our final velocity. And toggle meters per second. Now, that was completely unintentional, but a good opportunity to say, whenever you finish a physics problem, it is always a good habit to get into to check back at your question and make sure your answer actually fits with what's going on. It told me the scooter was increasing its speed, but I ended up getting a slower speed somehow, which tells me I definitely did something wrong, which prompted me to go back and check, find my mistake, and fix it before I locked in my final answer. All right, moving on to 12. Actually, I'm going to stop there for now because I'm about out of time. Keep an eye out for the other questions if you're interested in seeing them. They're solved the same way as the ones I've already gone through, but I'm about to have students in my room again, so I'm going to pause there so don't catch me in the middle of a problem, giving away answers to them too soon. If you have any questions, you can always post a private comment on Google Classroom, and I'm pretty good at answering those fairly quickly, and that's the best way. But if not, I hope everything goes well on our exam tomorrow.
But unfortunately, he never did return, as he forgot to do those questions before leaving school. He did, however, add background music to cover up his sniffles. Good day.